Hello, everyone. Good morning, good afternoon, or good evening. The authors, distinguished session chair, and invited guests. Welcome to Technical Session 4E. I'm Sanskriti Kamkar, and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development. That is ICT4SD 2026, held in Goa, India. This 11th edition of the conference is today in Goa, India, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for their presentation, followed by 2 minutes for Q&A. At the 9-minute mark, I will give a gentle reminder so that we can maintain a schedule. I request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during the session, please feel free to send me a message through the chat. Now, before we begin, it is my privilege to introduce the session chair for this session. Our session chair is Dr. Tanupriya Chaudhary, who is a professor at the University of Petroleum and Energy Studies in Dehradun, Uttarakhand, India. With over 15 years of academic and research experience, he has authored numerous publications in reputed journals, international conferences. His research interests include artificial intelligence and machine learning applications, specializing in algorithms, geoinformatics, AI in healthcare, ring computing, cloud computing, and verifiable computing. We are honored to have him chair this technical session. Now, let us begin with the paper presentations. Sorry for the interruption, guys. The internet is quite bad due to the weather. So, do we have Karthik Totlani with us here? Karthik Totlani, are you here with us? Okay. We'll be moving forward with the next presentation. Our next presenter is Anwar Khan, who will be presenting their paper on a hybrid machine learning framework for intelligent prediction and decision support systems. Anwar, you may please start your presentation.
Perfect. Thank you. Let me try sharing my screen. Did you give me the permission to share, or do I have to restart?
You can
Let me.
share. You do have the permission to share.
Oh, it's not allowing me. Let me restart quickly the Zoom. Sorry about that, guys. I think I can share it now. Let me know if you are able to see my screen. Okay, I'll
Yes,
start.
your screen is visible.
Perfect. So the topic is like a hybrid machine learning framework for intelligent prediction and design support. So my name is Anwar. I'm a senior staff software engineer working for John Deere. The introduction of the topic is like, the artificial and machine learning are essential technologies for prediction and then decision support systems. And then the idea is like how we can reduce the overfitting and underfitting of a system through the MLPs. So existing MLPs already have some approaches. Multiple algorithms can improve the prediction accuracy, robustness, and reliability. Here, what I'm going to talk about is like, hybrid approach between a random forest and XGBoost to enable better handling of complex data set and reducing bias and variance to improve the overall performance and F1 score. So the problem statement is like this: there are existing machine learning models. You can use one of the known models, and then you can do a better prediction. You can do some level of prediction with the high prediction accuracy, but for the complex data, it will not work really good. Also, the single model approach is sometimes leads to overfitting and underfitting, and also a poor generalization, which reduces the overall effectiveness of real world decision making. So currently, many current prediction frameworks fail to effectively balance the trade-off between bias and variance. So what I'm trying to do is like I'm trying to handle those variance and bias is this in this research approach. So there are already a hybrid model approach. So this is something that is not very new, but this is the machine learning models. Those are already having hybrid approach. They are very domain specific. They are not really good in some ways where the things are becoming generic. So you have to every time you have to retune, redesign, and then retrain those models. And those things are really computationally intensive, and that lacks overall scalability of the system. So to improve the prediction and support system, I chose a different solution. So the research objective, what I tried over here is like I developed a robust hybrid machine learning framework that takes care of the random, or that takes the random forest and XGBoost, and then complement each other's capabilities, and then try to provide a better F1 score. So overall accuracy, precision, and recalls are used to generate the F1 score, and that helps us to improve the overall performance. It also reduces the prediction errors by minimizing the bias and variance, and then also the decision support system is really, really reliable and scalable. So there are some literature reviews. There are some machine learning models that I've gone through. Those are having decision trees and high predictions pieces. There are also multiple algorithms people are using for the robustness and generalization of those models. And then there's a decision support system. Employ multiple hybrid ML frameworks that provide accurate prediction and all those things. So those are very specific to healthcare, finance, energy, and risk management. Here I'm trying to make it more generic. There are also common assemble techniques like boosting, bagging, model fusion. Those are helpful for reducing the overall effectiveness. So those are reviewed. And then there is the advantage of approach face challenges such as high competition complexity, limited scalability, and all those things. So comparative analysis of existing models. So there are differences that is in this research paper. They are talking about the multiple types of hybrid approaches. There are quantum plus classical approaches. There are benefits of each approach. There are very specific to one particular domain, healthcare or medical classification or energy system or cybersecurity. They have like a really good high accuracy in some cases, improve performance and all those things. So like if you see the references in the research paper, I'll not go in super detail just to save the time. But if you see all these research references, you will see like they are very domain specific, highly complex, limited generalization, complex architecture, and limited adaptability. So I'm trying to resolve those issues with this research paper. So the research paper is lake of generalization, generalized framework. The another problem is the high computational complexity, and then static model fusion strategies. Those are not really good. Also, limited scalability and adaptability. You cannot scale those models for really large data set and heterogeneous data set. So if the data is unstructured and you're trying to analyze those pieces, it really get complex. And then the need of improved predictability. So that's the idea that I'm trying to improve over here. So like higher accuracy, lower prediction errors. So the what is the proposed methodology? This is the summary of the paper. Ideally, like how it is working. Like there is an input data set, a structured, multi-featured, and targeted variables data set that is first cleaned up. So there is a data processing stage where like we are cleaning the data, doing the normalization, also doing the feature selection, which features are useful for our model training, and then we also chunk the data and then create like specialized features, and then we pass those information to both the models. So random forests get that information, and then also the XGBoost takes that information and then both generate their own predictions. Then there is a fusion matrix that takes the information from the both model, take the score, alpha and beta, and then multiply that score and then try to harmonize the idea, harmonize the values of those, and then trying to generate a final prediction. And then it provides a decision support system to different domain information. So if I go down, data processing, pre-processing hybrid model design is like methodology. What we are taking over here is like normalized data, performance structures, and this is the basic formula of like trying to do the normalization of the data. And equation two is like the random forest prediction piece. Now the fusion technique, what we are doing is like we are taking the both the output, both the prediction. So RF is random forest and XGB is the um, our our XGBoost model, and then alpha plus beta. That what we are trying to do is like it will always be sum as one. So what we are doing is like we are taking the information from the both the models, we are trying to multiply with that and trying to generate y, that is our prediction related to that. So result analysis, like I have run on the multiple data sets and try to analyze how accurate those are. So this is the accuracy score of independent model, so 91, 93, and then the proposed hybrid model takes the both the things, try to reduce the variance and bias from the both the algorithms and try to generate output. So you see if the average output of F1 score is comparatively higher than the independent score of this algorithms, machine learning algorithms. Uh, so these are our key findings. Based on these results, we can accurately say like there's a little bit of improvement, 2 to 3% of improvement in machine learning. It's a really big improvement because already you're trying to reach to a level and then you're trying to go as close as 100%. So any point percentage or any 0.1% even is a higher. The challenges of getting the improvement towards the 100 is getting tougher and tougher when you choose multiple models to generate the output. So overall improvement you can see over here on the screen where for the different matrices that we are using, accuracy, precision, recall, and F1 score, overall improvements got enhanced. And then the conclusion is the overall hybrid machine learning model integrated with the random forest and XGBoost. They develop a better prediction model and then decision support system. So and then the weighted approach is also really good because like you are giving a XGBoost a higher weightage when you are calculating the harmonic mean. So XGBoost is given a zero point 0.7 right now for this hybrid multiplication, and random forest is given a zero point 0.3. So you can see like that weighted fusion approach is good based on the efficiency of that model. And then the idea is the result demonstrator is like in the tables and all those things. So overall it is robust, reliable, and scalable. So anyways, like these are very famous prediction algorithms. When you're trying to scale it independently or in parallel, you can still do it because like it's not dependent on each other to calculate. So you can run in as a serial process, or you can run in parallel and try to get the information, and then finally you will use the your fusion approach to get the results. So future work, probably what I'm thinking is in the next research papers, we can more focus on the deep learning models and transformer-based models for unstructured data. That might be more helpful for unstructured data. So that might be able to help performance little more. And then adaptive weighing mechanism is really good because like right now we are giving a fixed values 0.7 and zero point 0.3. We want to try with the dynamically optimizing those values. That will give us a better results. And then larger real-time data, so we have tested on the lot of data, but now we want to move it to a more of a streaming data set that will give us a better performance in future. So we will try to give a diverse application domain, diverse data types, and try to get how it works, and incorporate explainable AI, XAI techniques to improve model transparency, user trust, and then the evaluation systems. So that what we're gonna plan with the XAI, or like building the guardrails around those systems. And then finally, we will try to push those systems to the edge computing environment and cloud environment to get the better decision systems, or like the real-time decision support. So these are my references, uh, and I think that's all from my side.
Okay, thank you for your presentation. What are the different data sets you have worked upon?
Yeah, so the good question. So I had taken some data from the Uber. I had taken the data from the travel industry, and then I had taken the data from the manufacturing telematics data. So these are the three data types I've been
And
using. These
is
are,
these data
yeah.
types are data are benchmark data sets?
Yes, so these are taken from the some are taken from the Tivolis. Those are the benchmark data set from those industries. And then also ran the benchmark. There are two types, like what we are using is like the three data set is already benchmarked, and then also we are doing a benchmarking on some level by saying like how this independent machine learning models are working on this data set. So based on that also we did a level of benchmarking on those things. So there are two levels of benchmarking or benchmark data we have used.
Okay, fine. Thank you.
Any other questions? Cool.
From
Thank you
participants, if any
guys. Thanks for
questions, you may
participating.
ask.
Yeah, sure.
Any participants, do you have any questions? I think that is it. Thank you, Anwar, for your presentation,
Thank
and
you.
Sachin for your questions and remark.
Perfect.
Up next, we have Kirtan Shah, who will be presenting their paper titled AI-driven analysis and prediction of actual hull potential of impressed current cathodic protection system.
Yeah, so am I visible? Hello.
Yeah, you're visible.
Yeah. Is my screen visible now?
Yes.
Yeah. So good morning to one and all present over here. Myself Kirtan Shah, and today I'll be presenting on AI-driven analysis and prediction of actual hull potential of ICCP system. So let's first see what is ICCP system. It is impressed current cathodic protection, which is a system which is used to prevent corrosion by applying electric current to the ship's base or the hull. So there are five main major components of ICCP system, which are anode, which made of inert material, which pumps the current; cathode, which is the ship's hull itself; DC source is a power source which helps to generate the current; automatic control unit helps to set the potential and adjust current. The last one is the reference electrode, which plays a major role in monitoring the potential of the ship. So let's see how this ICCP system works. So working of ICCP system. So first, the reference electrode over here monitors the potential of the ship. Then this potential is carried forwarded to the actual automatic control unit. Now this ACU in terms uh, tries to match the actual hull potential to the set potential, which is generated by the manual engineers. Now when the actual hull potential is above or below the set potential, the automatic control unit gives the command to the DC source to generate the current accordingly. And then the DC source passes the current to impressed anode, which in turn pumps the current to the ship's hull over here. So my problem statement is where the ICCP system helps to, preserve, or you can prevent the corrosion or rusting of iron of the ship's base. So hull corrosion increases maintenance and cost and reduces vessel service life. Now the second is, now this ICCP works in such a way that the engineers have to monitor the set potential, the current, the voltage accordingly. And the third is dynamic and nonlinear behavior. So during the sailing of ship, there are many factors such as salinity, temperature, winds, which affects the behavior of ICCP system. So that is also taken into consideration while we are building a AI model. So first, my objective is to analyze the relation between current, voltage, hull potential. Second is to identify how the salinity, speed, location affects the uh, influential of ICP system. The third is to predict the actual hull potential. So there are four features in general. First is set potential. Second is current and voltage. Now this current helps to generate the actual hull potential of the ship. The fourth one is to identify the best model out of the multiple regression algorithms which I have used, and to select and then give them to the engineers. The key research gaps are, the first is simulation based validation. So far existing ICCP literature survey says about simulation based studies rather than real operational ship data. So I've used real operational ship data. The second is limited long-term operational analysis. So in long term, ICCP behaves dynamically. So the pattern is very hard to and very challenging to discover. So I've used the 8 years of data for my prediction of model. The third is limited generalization across ships. So as we saw that in ICCP system, the ships have uh, the ships is located the ICCP system is located on the ship, and this anode which pumps the current are of different classes. So suppose if one class of the ship contains four anodes, the second class contains eight anodes. So I have not limited my ship's classes to one. I have given multiple one. The fourth is limited dynamic feature analysis. So there are, as we saw, that there are many features such as hull potential, set potential, current voltage. So we will study, and I have analyzed all the features which will help to understand the behavior of ICCP system. So data to model research pipeline. So first I have collected the data. I have digitized the 10,000 plus records from eight plus years of active ship operations. So parameters are set potential, anode, current, voltage, and hull potential. The second is cleaning, cell corrections for consistency. I've handled missing values where the current values or the voltage values are not given. I've indicating the outlier and filtering them out was a key task in cleaning. The third is features where I've selected current voltage as my key features. The second is the defined target variable is actual hull potential. The third is feature alignment and scaling. The fourth is where I will analyze the data of ICP system. So I perform EDA, the correlation between current and voltage, set potential and actual potential. Also, the current versus speed of the ship has also been analyzed, which I will show you in detail. The fourth one is identifying patterns and relationships between all the features. The fifth is modeling. So I have evaluated 23 machine learning algorithms where I have also validated using tenfold cross validation. And at last, the winning algorithm was random committee, which I'll show you. The dataset overview. So I've used 10,000 plus records. It consists of a span of 8 years. I've used 3 inputs and 1 output, regression of 23 models, and my target is actual potential. So this is an overview. So feature selection, over here you can see that set potential is the preset potential, which is normally around minus 850 millivolt. The total current is summation of individual anodes. So as I said that in ICCP system, anodes help to pump the current. So based on the class of the ship, there are 4 anodes, there are 8 anodes. So this milliamperes of currents are summarized, and we have did addition of all the 4 anodes or 8 anodes and given a one column such as total current. Then the third feature is voltage, output voltage, where this voltage drives the total anode voltage. So my output feature is actual potential. This potential is generated by the current of the anode of the ICCP system. So moving to the data analysis, this is voltage versus current. Okay. So as we know by Ohm's law that voltage and current are direct proportional to each other. So as we can see, both current and voltage are following the same path of each other. But in 2015, as you can see, the current and voltage are meeting at the same point. So this is due to in 2015, the ship was sailing, and the ship sails, the current also increases because the current requirement is more since the corrosion chances are more. Okay, so it operates near its limit, but as we can see, this is meeting each other. This should not be the case. So this was concluded that anode was in failure mode, and it was replaced by, it was followed by the replacement by the engineers. So rest in 2016 and 17, there is the same scenario. The current and voltage are following each other's path. Set potential and actual potential. So in 2000, so set potential and actual potential should be nearly equal to each other, as we saw. That ACU ACU of the ICCP system helps to maintain the set potential and actual potential close to each other, so there is no corrosion on the base of the ship. So in 2012, you can see there is a deviation in both set potential and actual potential. This is due to the major maintenance the ship was under major maintenance activity where anodes and reference electrodes were under replacement. Now, same goes for 2017, where the ship was having high current impression throughout the year, potentially causing the actual hull potential to diverge from the set value. So this is due to, as I said, that current and actual potential current helps to generate the actual potential. Now, when the ship is sailing, the ship is at high speed, the current requirement is more, and so thus the actual potential is also required more. The third one is current versus speed, where this concludes that current and speed are not related to each other because in at 13 knots ship is under 1.8 knots, but
Excuse me,
at
Kiran.
hello.
Sorry to interrupt you. This is just a gentle reminder that 9 minutes are over. You have 1 minute left for your presentation.
Okay, so my best performance was of random committee where it achieved 0.915 correlation uh, out of 23 algorithms. So why random committee was selected? Because it captures nonlinear relationship, robust to noisy operational data, highest correlation, lowest mean absolute error. The actual was versus predicted uh, scatter plot, where all of the points are close to each other on the red line. Residual is also scattered plot, which shows that actual minus predicted values are very close to the zero red line. So performance validation, I have did tenfold cross validation. So this is my average mean absolute value, mean R square, RMSE, and the confidence interval is 95%. So final contributions are it helps to operational data analysis, which can be calculated using this data. The third is machine learning prediction, where the feasibility of machine learning algorithms are has proved, and this also helps to for decision support through which I have created a UI which helps to uh, predict the actual health potential based on the three features. So thank you from my side.
Yes, it's a nice presentation, but can you please explain that how you have examined or performed 23 algorithms in a single time?
Yeah. So I've used a Weka tool, WEKA, which helped me to input my data. Okay,
Yeah,
and
Weka tool is fine. It's a data mining tool, but have you statistically checked your informations as well? Otherwise, these all are synthetic informations.
no, I have checked as well. I mean, you if you see at the graph, okay, this is of random committee,
No, no,
and
I
this
am asking about statistical informations. Have you used
uh,
some testing process or testing procedures?
yeah for so this can performance validation, can full cross validation. Is this what you are asking for, sir?
No, no, testing process is different. Okay, fine. You may please check it out after your presentation. It's a
Okay,
nice presentation indeed. Kindly check.
okay,
Otherwise, you may use Hugging Face as well.
okay, sure. Yeah,
Okay, okay. Thank you. I am
yeah.
asking about T-test, Z-test, and other test procedures. Validations is fine.
Okay, okay,
You may please check it out so that the results your algorithms are giving and also the statistical measurements are giving maybe plus minus 10% variations may be there, then you
okay,
can say that your results are fine.
okay, sure.
Okay, okay, fine,
Thank you.
thank you.
Thank you for your presentation, Kirtan.
Yeah.
Do any other participants have any questions for Kirtan? Okay, I guess I have no questions.
Thank.
Next presenter is Amanpreet Singh, who will be presenting the paper titled Customer Perception of Value as a Moderator in Health Insurance Adoption, examining the effects of awareness, accessibility, cost, and trust with customer satisfaction as a mediator. Amanpreet, you may please start your presentation.
Yes. Good morning, everyone. My today topic for presentation is customer perception of value as a moderator insurance adaptation, examining the effect of accessibility, cost, trust with the consumer as mediator. Outcomes of my research is first part is the introduction and next is a literature survey. The next is problem statement, methodology implementations, result discussions, conclusion and references. First of all, we come on introduction part. In this, we introduce about the insurance. Insurance and medical and health insurance I capture here in my research. This plays a critical role in reducing the financial burdens on the caused by unexpected health issues in India. The speed and increase in the awareness campaign, digital insurance platforms, policies, reform, and health insurance inconsistent across the different demographic and socioeconomic groups, indicating the presence of multiple behavior and structures of insurance sector. Key findings and determine influencing the health insurance adoption, including the awareness of insurance policies, accessibility of insurance of premium, trust in insurance provider, which collectively shape the customer decision making, purchase intention. Customer satisfaction act as the important mediating mechanism that transport the informational, economic, and relational into the actual adaptation behavior consistent with the expectancy and confirmation in the theory. Customer perception of value function as a moderating factor because the customer evaluate the insurance procedure by common benefits against the financial sacrifice, thereby strengthening the weakening and influence of awareness, trust, and satisfaction. This study possesses the moderated mediation framework integrating the suspicion and perceived value mechanism of the understanding of health insurance adoption behavior and support customer centric insurance policy design strategic recommendation. Existing existing literatures on the health insurance adaptation uh, previous show that the people buy the health insurance based on the both financial and personal factors. Important factors include the awareness, accessibility, premium, cost, trust, and perceived values. Better awareness help the people understand the insurance policies and make the uh, policies inform the decision, make the decision regarding buying behavior. Easy access through the online platforms, mobile apps make the buying and using the insurance more convenient. Premium cost is the major factor. High premium reduce the chances of buying insurance. Trust in the insurance companies increase the customer confidence and willingness to purchase the
Can
insurance.
you please come to your own work?
Yes, sir. Yes. Yes. Methodology, the study adopted the quantitative and explanatory research. The quantitative method is of the survey is data collected. Data is collected through the questionnaires from 320 respondents in the Punjab. Respondents were collected through the both online and offline survey. All the questions are measuring using the 5-point Likert scale. The data was analyzed structural equation model SAM using the PLS, AMOS, and SPS software. Analysis tested reliability, validity, mediation, and moderation relationship between the variables. Findings help to explain the factor that influence the people decision to adopt the health insurance. Results: awareness, accessibility, and trust. Methodology first I explained that through the figure the buying behavior is affected by the customer awareness of the insurance policies, accessibility of insurance services, cost of the premium, trust and insurance providers. All these are affect the customer. In this figure, I explain the search methodology and data collection flow. In this, when the satisfaction trust line is increased, then in the graph, like shown in the graph, the satisfaction of the customer increased. The results are the awareness and accessibility and trust had the positive effect on the customer satisfaction and health insurance. High premium had negative effect on the customers and making the people less satisfied and unlikely by the insurance policies. The study found the awareness, accessibility, trust, and cost explained about the 50% of customer satisfaction. Customer satisfaction strongly increased the chances of the health insurance adaptation. Customer who felt they received the good value of their money, the more satisfied and more likely to buy the health insurance. Search model predicted that health insurance adaptation with the 84.4% accuracy, showing the relevant result. Overall, the model was accurate and stable. Conclusion: the study identified that these are the my results, and the conclusion part is: conclusion, the study identified that factor that influence the health insurance adaptations, awareness, easy access to insurance, trust, increase the customer satisfaction, high premium cost the reduce the customer interest and willingness to buy the health insurance. Customer satisfaction play an important role in the encouraging the and willingness of the buying behavior. Customers are more likely to buy the insurance when they feel they get good value of their money. Research model give accurate and reliable results. The study suggests that the insurance company should increase awareness, offer affordable premiums, improve the digital services, and build the customer trust to encourage the more people to their buying health insurance. These are the references I used, and thank you from the my side. Any questions?
Dr. Tanepriya, do you have any questions?
Any questions, sir?
Okay, I think there are no questions. Thank you for your presentation.
Thank you, ma'am. Thank you. Okay.
Up next, we have Kirtana M presenting their paper titled Machine Learning Approach for Disease Prediction Using System Disease Mapping.
Is my screen visible, ma'am?
Yes, it's visible.
I am Kirtana M. Today I am presenting our work titled Machine Learning Approach for Disease Prediction Using Symptom Disease Mapping. Our research proposes a hybrid machine learning framework that combines random forest classification with k-means clustering to improve disease prediction based on patient symptoms. These are the contents of our work. Disease diagnosis is one of the most challenging tasks in healthcare because many diseases exhibit similar or overlapping symptoms. This often leads to delayed diagnosis, misdiagnosis, or inappropriate treatment. These challenges are even greater in rural and underserved areas where specialist healthcare is limited. Recent advances in artificial intelligence and machine learning have enabled intelligent systems that can analyze medical data efficiently and assist healthcare professionals. Our work aims to develop an accurate disease prediction system using a hybrid machine learning approach. Several disease prediction models have been proposed using role based systems, machine learning algorithms, deep learning techniques, and healthcare chatbots. Among these, Random Forest has demonstrated excellent classification accuracy because of its ensemble learning capability. Similarly, K-means clustering effectively groups similar symptom patterns and improves data organization. However, existing systems still faces challenges in handling overlapping symptoms and complex symptom disease relationships. Therefore, our proposed model integrates both techniques to overcome these limitations. Many diseases share common symptoms such as fever, headache, and cough. This makes diagnosis difficult and increases the chances of incorrect
Keith, you're not audible. Are you here with us?
and improves features representation. The cluster data was then provided to the random forest classifier. Random forest builds multiple decision trees using different subsets of the training data. Each tree independently predicts a disease, and the final prediction is obtained through majority voting. Finally, the model was evaluated using the accuracy, precision, recall, F1 score, and confusion metrics.
Screen is not visible.
Um, 1 minute, sir. I think network problem. Now it is visible, sir.
Yes, yes.
Okay, sir. Thank you, sir. The data set, this was what I was explaining previously. Our methodology consists of five major stages. First, we collected the data consisting of 4,962 patient records and 132 symptoms and 41 diseases. And then the pre-processing was applied. After pre-processing, games clustering was applied to group patient having similar symptoms patterns. This reduces variability in dataset and improve feature representation. The cluster data was then provided to the random forest classifier. It builds a multiple decision trees using different subsets of the training data. Each tree independently predicts a disease, and the final prediction is obtained through majority voting. Finally, the model was evaluated using accuracy, precision, recall, and F1 score. The dataset consists of 4,962 patient records, 132 unique symptoms, and 41 diseases. The data was divided into 80% training and the 20% testing part. This split enables the reliable evaluation of the model's performance on unseen patient records. The algorithms used or our hybrid framework combines two machine learning techniques. The first is the random forest, which is a supervised learning algorithm. Instead of relying on a single decision tree, it builds multiple trees and combines their prediction through majority voting. This improves prediction accuracy while reducing overfitting. The second algorithm is K-means clustering, which is an unsupervised learning algorithm. It groups patients with similar symptom profiles into clusters, thereby reducing data variability and improving classification performance. The integration of these two algorithms significantly enhances disease prediction accuracy. The proposed model achieved excellent performance. It obtained the accuracy of 95.2% and precision 93.8 and recall 96.1 and F1 score 94.9 for random forest. And these results demonstrate that the proposed hybrid framework provides a reliable and accurate disease prediction. This is a confusion matrix. It illustrates the prediction performance of the model. Most values are concurrented along the diagonal, indicating correct classification of disease classes. Only a few misclassifications occur between diseases having the similar symptoms such as allergy and asthma. Overall, the confusion matrix confirms that the robustness of the proposed approach. In conclusion, we developed a hybrid disease prediction framework by integrating k-means clustering with random forest classification. The proposed model effectively handles complex symptom disease relationships and achieved an overall prediction accuracy of 95.2%. This framework has strong potential for supporting clinicians in early disease diagnosis and intelligent healthcare decision making. As future work, we plan to integrate larger real world clinical datasets, explore deep learning techniques to develop a web and a mobile based healthcare application, and to integrate the system with the telemedicine and IoT platforms for real time disease prediction. And this is our work. Thank you all.
Sorry, ma'am. Here, due to heavy raining, my network is fluctuating at Dehradun. So for this presentation, no question from my side.
Okay, sir.
Mm.
Thank you for your presentation, Kirtina.
Thank you, ma'am.
Up next, we have Swayam Shah, who will be presenting their paper titled Mentor Connect, a modular web framework supporting inclusive mentorship and knowledge continuity.
Yes, thank you, ma'am. Um,
Swayam, please start your presentation.
yeah, is my screen visible?
Yes.
Okay. So, good morning, everyone. I am Swam Shah. I'll be presenting my paper, Mentor Connect, a modular web framework supporting inclusive mentorship and learning continuity. So, first is project conception and initiation. Abstract. Mentorship is very important for academic and career growth for any student, whether they are pursuing any field. So there are many challenges for effective mentoring. Like there may be no structured mentoring interactions or platforms or environment. So we introduced a web-based mentoring platform, Mentor Connect, that offers a secure, scalable, and organized mentor-mentee interactions. We developed our system using Python, Django, and Django framework to facilitate real-time communication and effective mentoring management. So Mentor Connect features secure authentication, role-based access control, student profiling, management of students' academic records, real-time communication used via video call, video conferencing, or via chat, and also uh, real-time notifications to notify about any meetings or scheduled sessions. The platform improved the effectiveness of mentoring by uh, making the sessions more accessible, effective, and easy to track than traditional mentoring methods. Objectives which we fulfilled are to implement role-based access control via email verification via OTP, enable real-time chat functionality with document sharing between mentor and mentee using WebSockets and Django channels, to enable mentors to view and download mentee uploaded documents, what mentees have uploaded, their whether it is internship records or certifications courses or any other records. Then next, to facilitate visualization with detailed data analytics of mentee data and generate reports in PDF and Excel, to allow mentees generate profile overview based on uploaded documents, which may help mentees to create resumes when they are appearing for jobs and placements. These profile overviews are based on internship and certification records, results, etc., which the mentee has uploaded on the platform. Then to provide calendar booking for session scheduling based on mentors availability, we have used Jitsi for it. Then to allow mentors record mentor-mentee interactions along with AI-based agenda summarization, whatever the agenda of the mentoring session is, and we have used the CNN model for it. That model is Facebook part large model, Hugging Face model. And also mentors can record attendance of the mentees, those who have attended the session. So the attendance statistics are also shown to the mentee on their dashboard. And also we have implemented activity logging and log monitoring to improve traceability. Next, these are the papers which we have referred. First is role of generative AI in personalized learning for higher education. From this paper, we understood the role of generative AI and implemented a CNN model to create agenda summaries of the agenda. Then second is impact of technology on mentoring in academia, leveraging digital platforms and virtual mentoring. By referring this paper, we implemented session scheduling using Jitsi. And third paper is enhancing collaborative learning and e-mentoring in a smart education system in higher education. From this paper, we understood the importance of face-to-face mentoring and how it is important that the mentoring must be structured and not unstructured or so. Next problem definition is in academic environment, students face challenges in finding suitable mentors who align with their goals, while mentors also struggle to uh, manage multiple mentees due to lack of unstructured or centralized lack of structured or centralized system. So this creates coordination gap and scattered feedbacks and inefficiencies that hinder long-term development. To overcome these challenges, we proposed Mentor Connect, a unified web-based platform that overcomes these challenges like lack of centralized systems and unstructured mentoring. So we implemented session scheduling, real-time communication, resource sharing, and progress tracking into a single system that makes the process centralized. This is the architecture of our system. We have three types of users: admin, mentor, and mentee. Mentors can assign the mentee using a Moodle ID or their username. Basically, Moodle ID is the username assigned by the institution. These are the client interfaces, role-based dashboard for all the users, mentor, mentee, and admin. Chat interface, profile management, file upload and download, mentor, mentee interaction UI, meeting scheduler, resource, student query handling, whether student has any query related to sessions or any other queries. Then next is mentor authentication and access control. Secure login using OTP verification, role-based access control, session management, mentoring and communication services, mentor-mentee interaction tracking, real-time chat, notification, reminder engine, query management, meeting scheduling, and activity log. This is the academic and analytic services, profile management, internship and certification records. Next, and backend services. We have used Django framework for backend, and frontend is developed using HTML, CSS, JavaScript, and Bootstrap. And this is our database and storage, user accounts, profiles, internships, certifications, projects, semester results, mentor-mentee interaction, analysis, activity logs, meetings, notifications, chat messages, queries. File storage is Django's file storage, and external integrations are email notification service, Jitsi Meet integration, Docker deployment, and cloud hosting support, which is a future scope. Sorry. So this is the homepage of our website where mentee, mentor, and admin can log in to the respective dashboards. This is the mentor dashboard where mentors can see top performing students, which is the top division. Pending notifications are displayed here, and here mentors can add their mentees via Moodle ID or username. This is mentee dashboard. Your mentees see their last 30 days upload summary. This is mentor-mentee interaction page where mentees can interact with their mentor by sending requests to initiate chat, schedule meetings, and upload any queries related to sessions. This is mentor side mentor-mentee interaction page where mentors can add interactions. Here they can generate a summary of the mentoring agenda or record attendance of the mentees who were present in the session. And this is the admin dashboard where admin or head of the department HOD can view every detail what the students have uploaded and generate reports from this dashboard. Next, this is activity logging interface where each and every activity that is performed on the platform is recorded with changes, what have been changed and what was old data, what is new data, IP address, browser data, everything. Next, conclusion. So Mentor Connect is a Python-based mentoring system which is developed to execute mentoring activities in an appropriate and safe web-based interface. The system developed has given role-based access facilities to administrators, mentors, and mentees to develop customizable interfaces and control application data. The system has the in-depth mentee profile and document management, which helps students create profile overviews that help them in creating resumes for their placement preparation. Then session scheduling facilities, real-time chat, and activity logging also helps the admin and mentor mentees to connect and carry out mentoring sessions in a structured and centralized way, which which many institutions lack. This our platform can help carry out mentoring sessions in a structured and centralized way. Thank you. And these are the references which we have used for our project. Thank you.
How many data actually you have checked? How many data you have checked actually at your sites?
Sir, can I show you my website?
Yeah, please.
Yes, sir. Sir, so this is our website. For now, this is running on localhost. We are also deploying it on our college domain, but due to some due to college since college is not yet open, so we have not deployed it. But once the college will restart, we'll deploy it. So this is mentor side page. Let's say I register one mentor, Abhishek. So OTP will be sent to this mail. So here is the OTP 550149 550149. Yeah. So this is mentors dashboard. From here, mentors can add mentees using their Moodle ID, for example, 221041115. This is the Moodle ID of one of the students. Enter. This is already assigned to another mentor. So it will show mentor assigned to Yug Mukesh Shah. Mentee assigned to Yug Mukesh Shah. Now I'll show the account of Yug. Yeah. So this is mentor's dashboard. Whichever mentee will be added by the mentor will be shown here, and the progress is recorded here. Progress is recorded based on internships, projects, certification or courses, and semester results that the mentee has uploaded up to date. So this is this Swayam Shah has uploaded all the documents from these four categories. So his progress is 4 on 4, and whichever mentee is lacking in progress, mentors can send reminder to all of them. Reminders will be sent via in-app notification
Okay,
and
it's fine.
also
It's
via
fine.
email.
We may go to the next presentation. It's a technical paper actually, technical implementation. You have just make a report and publish it. It's fine.
Yes, sir.
And one more query, session organizer, can you please switch on your mic?
Yes, sir.
Yeah, the second presentation, when was presenting one faculty, that time my internet was not working. I have a query for him.
Yeah, sure. Let me see if they are still in this meeting. Kirtan Shah, are you still in this meeting?
Yeah, I'm there. I'm present.
Yeah.
So sir, I have a question for you.
Yeah.
Can you please let me know your topic name?
AI-driven analysis and prediction of actual hull potential using ICCP system.
No, actually, who is working on insurance?
No, I'm not of insurance.
Okay, ma'am. Then come to the next presentation, please. Thank you.
Okay. Um, Now we have Abhishek Patel presenting the paper titled Optimized Decision Trees for Monthly Potential Evapotranspiration Prediction, Classical versus Meta-Heuristic Tuning in Raipur, India.
Is it visible, madam, in my presentation?
Yes.
Okay. Okay. Hello, everyone. I am Abhishek Patel, and I am going to present my paper, Optimized Decision Trees for Monthly Potential Evapotranspiration Prediction, Classical versus Meta-Heuristic Tuning in Raipur, India. Introduction about the paper is accurate potential evapotranspiration prediction is essential for irrigation, drought management, and water resource planning. PET refers to the maximum amount of water that would evaporate and transpire from the green surface. Machine learning models can better capture complex hydrometeorological relationships to predict potential evapotranspiration. Our objective is to develop decision tree models for monthly potential evapotranspiration prediction. Next, to compare classical hyperparameter tuning methods with meta-heuristic optimization methods. To evaluate predictive performance using various evaluation matrices. To identify the most effective optimization strategy. Our data set descriptions are the study area we have focused on is Raipur, Chhattisgarh area, and monthly potential evapotranspiration was collected using satellite-driven meteorological data. In the data set, variables are PET, maximum temperature, average temperatures, minimum temperatures, and relative humidities that are used in the models. Data pre-processing here, since it is not using sensor data for data collection, the data is consistent and standardized observations are there. So no missing values are also there. Here we have done the min-max scaling for the normalization purpose. The formula is given here. Methodology is first we have used 4 baseline models called linear regression, decision tree, multi-layer perceptron, and support vector regression, in which decision tree was selected as a primary model due to the superior performance. You will see the performance later. And after that, we have applied hyperparameter tuning in the decision tree models, which was categorized as the classical and materialistic approaches. The approaches are given as given. Classical approaches, one is grid search, another is random search, and meta-heuristic algorithms like well optimization algorithm, harmony search, genetic algorithms, particle swap optimization, and sine cosine algorithms. Experimental setups are as follows. For training and testing, we have split it into 80-20 ratio. We have used evaluation matrices like, mean square error, mean absolute error, coefficient of termination, and mean decimal accuracy. These are the results for the all models as well as with optimization techniques. Top 4 entries are the baseline models in which we can see the decision tree is performing better than others. It is underlined in the second row. Then after we have choose decision tree and applied various optimization methods in which we can see the whale optimization method is performing better than other optimization methods. Results are, as we discussed, DT outperform other baseline models, and optimization, we have seen the optimization methods also improve the predictive performance. Here, whale optimization algorithm and as well as harmonic search significantly reduce prediction errors, which we can see it reduces up to 14% RMSE as compared to the baseline DT model. Here, this is a graph showing the convergence of all methods, all optimization methods. Here we can see the whale optimization method converts too fast as compared to the others. In conclusion, optimized DT model provide accurate monthly potential evapotranspiration prediction, and the whale optimization algorithm emerged as the most promising optimization technique. Results can support irrigation, scheduling, and sustainable agriculture. In future, we can apply deep learning, transfer learning, and multi-model climate datasets as well. That is it from my side. Any question?
What kind of
Sir, your voice is not audible, sir. Sir, your voice is not audible.
am I audible to you?
Now it's okay, sir.
What kind of optimizers you have used?
5 optimization techniques I have used, sir. Let me
No, I
show
am
the.
asking about optimizer. Specifically, name the optimizer's name.
Sir, these methods I have applied in the decision tree models for optimizing 2 classical models and the 5 heuristic algorithms.
Can you please explain any of the model?
Any of the
Sorry?
optimizations, sir.
Yeah.
Okay. Sir, like in genetic algorithms, sir, it will use the property of genetic algorithm in which the three main steps in genetic it will use to optimize to choose the best parameters we have given in the algorithm. Uh, uh,
Okay, it's fine. Thank you.
okay.
Thank you for your presentation, Abhishek. Up next,
Thank you, madam.
We have Siddesh Maitri presenting the paper titled Simulation-Based Cyber Range for Education.
Can you confirm me? Is my screen is visible?
Yes, it's visible.
Yeah. Hi, I'm myself Siddesh Maitri from Reva University. Today, my topic is based on Cyber Range Simulation Lab for Education. So this project is focuses on creating a low-cost cyber range where students and professionals also can safely learn cyber security by performing and analyzing cyber attacks in controlled environment. So in this agenda of my presentation, first I will going to introduce about my project. Then we'll discuss upon literature review, problem statement, and has gone still references. So a cyber range is a virtual environment where cybersecurity attacks and defense can be practiced safely. Many organizations use a cyber range to train security professionals. However, commercial cyber ranges are expensive. As we see, many of the companies are paying many much dollars and all. So many academic labs are too simple to provide real world experience. Therefore, the aim of this project is to develop low cost, open source cyber range that provides enterprise like and training using freely available tools such as an virtual box. PFSense is a firewall which is open source and free. Kali Linux and Wazoo. So, cyber range is a safe, as I said, a cyber range is a safe copy of a small enterprise network. So, I'm using a LAN, WAN, and a PFSense bridge segments. So, PFSense is a firewall. So, these are the literature survey. Literature review, I reviewed several papers. Most existing solutions are designed for foreign governments or large organizations. All through they provided advanced training, they have expenses, they are more expensive and require powerful infrastructure. So as more powerful infrastructure like means like more data like and more GB RAM and ROM also. Some low cost solution exists, but they do not include centralized monitoring like an SIEM tools. So problem statement. So the main objective of this provide a safe and affordable environment where students can learn, perform attack and defense exercises. So the cyber range should detect attack quickly, help administrator respond effectively, and restore service rapidly. All activities remains inside the virtual environment without affecting real world. So project objectives. The first, to build an enterprise like an cyber range, you are using virtual box and PFSense. So both are freely available in internet. So second is to simulate cyber attacks such as an synchronous floods and ICMP floods. Third, to detect an attack using Wazoo and firewall logs. So we have to certain rules in the firewall logs, and Wazoo is a dashboard where we can see whether the attack has been successfully or not. So, sorry, project methodology. The methodology begins with creating a virtual environment. Attack traffic is generated from the Kali machine. PFSense monitors and controls the network traffic. Wazoo collects the logs from different systems and make them into a single timeline. Finally, all collected data will be analyzed, measured, attack detection time, response time, and the system recovery. So these are the hardware requirements where I have deployed my cyber range. So as I said, 24 to 32 GB of RAM is better, and SSD is 250 GB, and TFSense and software like, and we need an virtual box where we can run multiple like an Ubuntu, Windows, Vazoo Manager, like that. So here is a software design. So we here we can see an Kali. Kali is an attacker machine, and PFSense which makes an a WAN and a line like a bridge. So next Vazoo server and Ubuntu server, and we have an Ubuntu user. So from a Kali, we have to it will attack an Ubuntu user. So we can see the PFSense dashboard in a Ubuntu user, and the system logs will be generated and goes into an Vazoo server, and the Ubuntu web server and the agent is connected to an Vazoo server, and all the logs will be displayed yeah, in the Vazoo dashboard, where we can access in an user Ubuntu user. So implementation. During implementation, I have configured a static IP address for all virtual machines. PFSense routes traffics between LAN and WAN and forward logs to Vazoo. Kali Linux generates attack traffic. The web server hosts the vulnerable application, while the Ubuntu user machine verifies the services is available before, during, and after attacks. So these are the testing and validation. This is the Kali mission, and I have attacked using Hydra. And here's the result where we can see in the Wazoo dashboard. Yeah, to validate the cyber range, I performed an SSH brute force attack using Hydra from a Kali Linux machine. Yeah, here it is present. The attack is generated multiple logs attempts against the target server. So here we can see the multiple logs here, and Wazoo successfully detected the attack within seconds. So it generates approximately 6.5K SSH. This confirms that an attack detection and monitoring pipeline works correctly. So these are the main references. These are the main research papers and publications were referred during the development of this project. So they are provided guidelines for designing the cyber range and selecting appropriate technologies. So in this conclusion, this project demonstrates that a low-cost cyber range can provide realistic cybersecurity training for open source tools. It allows students to safely perform cyber attacks, monitor events, and practice incident response. Uh, Thank you.
Can you explain the framework clearly?
Yeah. Yeah, our framework is an simulation cyber range designed for an cybersecurity education. Sir. It creates a safe and isolated enterprise network inside a virtual box. So everything is done in a
No, no,
local.
I am asking about what are the specifications of that.
Okay, just a second. Sir. Yeah. Yeah, Kali Linux is an attacker, and PFSense firewall, where we can write on a set of rules and regulations, and here is a web server. The Ubuntu web server host is a vulnerable application where we can such as an Apache and DVWA. This machine is a target machine, so Ubuntu user machine, the Ubuntu desktop machine acts as a normal user where we can access an Wazoo server, and we can also see then a PFSense firewall whether it is running or not, and Wazoo SIEM. So as I said, WASO is a security information and event management system. It collects all the logs from the PF Sense and WASO web server and detects the suspicious activities and generates the alert in real time, which shows in a dashboard. So VirtualBox, all these machines are run inside the VirtualBox.
Okay, sir. Okay. Thank you.
Thank you, sir.
Thank you for your presentation. Now we have Nityam Tikhe presenting their paper titled Translation and Transliteration of Indian Languages, a comprehensive framework using neural networks and multilingual models.
Hello, is my screen visible?
Yes, it's visible.
Okay, so good morning everyone. I am Nityam Tikhe from Bharati Vidyapit, deemed to be University, Pune. So today I will present our research titled Translation and Transliteration of Indian Languages, a comprehensive framework using neural networks and multilingual models. So this research focuses on improving the multilingual communication by developing an AI-based framework for translation and transliteration of Indian languages. So the agenda covers the motivation behind our work, the proposed framework, methodology, experimental results, application, and finally the conclusion. So India is one of the most linguistically diverse country with 22 official languages and over 700 spoken languages and more than 1600 dialects. While this diversity is culturally rich, it creates a challenges in digital communication and information access. So the most existing systems mainly support English and provide limited direct translation between Indian languages. To address this, we proposed a hybrid framework that combines neural machine translation and transliteration, supporting 21 Indian languages across the 12 different scripts. So the main challenge is that Indian languages use different scripts and have complex grammatical structures. Many regional languages also have limited training data, which making accurate translation difficult. So additionally, code switching and inconsistent transliteration reduce the performance of the existing systems. So therefore, there is a need for the unified and scalable solution which supports the multiple Indian languages. So the main objective is the framework follows a simple pipeline. So first, the input language is detected in first step. Then the text is processed and normalized. The translation is performed using the transformer-based neural machine translation models. And after translation, the transliteration is carried out using the Akshanta dataset and Google Transliteration API. So finally, the output is evaluated before being presented to the users using the BLU, Meteor, and CHRF. So the methodology consists of the five stages. First is language detection, identifies the input language. Second is pre-processing, which cleans and prepares the text. And third is the transformer models, perform multilingual translation. And the fourth step is the transliteration, converts the text between the different scripts. And finally, the results are evaluated using BLU, Meteor, CHRF scores, and the human evaluation. So the results, our framework achieved the encouraging results. The transliteration BLU scores ranged from 26.4 to 34.7 across different language pairs. And for the transliteration, the system achieved an overall accuracy of 92.4% with 24.3% accuracy for English to Hindi and Hindi to English transliteration. So human evaluation is showed good performance within an average fluency scores of 4.2 out of 5, and 87% evaluators rated the system as good. So this results demonstrate the effectiveness of the hybrid approach. And analysis, the results we observed that combining neural machine translation with the actionable data set significantly improved the transliteration accuracy. The framework is also performed well on low resource languages and handle multilingual inputs more effectively than traditional approach. They show that hybrid AI systems based are promising for multilingual applications in India. So the applications of a framework can be applied in several real world domains. It can support multilingual education, government services, digital publishing, and social media communication. It is also improve the AI chatbots, virtual assistant, and customer support systems by enabling the communication in regional Indian languages. The conclusion is to conclude we proposed a hybrid AI framework that combines neural machine translation and transliteration. So the framework supports 21 Indian languages and 12 scripts, achieving higher translation quality and 92.4% transliteration accuracy. So we believe this work can contribute towards the making digital communication more accessible across India's multilingual environment. So thank you for your attention. I would be happy to answer any questions.
Can you come to your framework and what are the
Yeah,
languages it can support?
okay. Yes, sir. Um,
Please explain
so
the framework. Huh?
So the first step is the input of the raw text and Indian languages. For example, Namaste, how are you? It's in Hindi, but like we write in English. So it's a translated text. So pro, uh, first we do the process of language detection. So we identify this language as Hindi. Then after we process the text normalization, the noise removal, stop word handling, script standardization, and normalize this text. Then it is translate using the transformer-based neural machine translation models. Then after translation, it's also transliterated, like converting the script like Namaste, how are you? So uh, and in a Hindi script like Namaste. So it's written in Hindi, Devanagari script, and then it's evaluated using the BLU and Meteor CHRF, and quality is evaluates using this evaluation, and then the output is presented to the users.
What are the data
Also,
sets you have used here? Can you
sir,
showcase the data sets and the characteristics of the data sets?
so we have used the Akshanta data set of Google, and we have also manually created a dataset and a JSON frame and JSON files in which the keywords are there for the Hindi slangs and to identify the slangs which are common in languages like Hindi and Marathi.
Okay, okay, fine. Thank you.
And the second question is the how many languages can support. So the framework supports the 21 Indian languages and across the 12 scripts. So for example, the Hindi, Marathi, Bengal, Tamil, Telugu, Kannada, Malayalam. But in the majority of datasets we have is in Hindi, Marathi, which are the major spoken languages. But still we have lacked the datasets which are very uncommon languages, which are mostly Northeast languages and the northern languages, which can be Dogri and which are more regionally, and they are not having multiple datasets and many information. Yep. Any more questions, sir?
No, no, thank you.
Thank you, sir.
Thank you, Nitin, for your presentation. Now we have Harshana Makwana presenting their paper titled The Ensemble, a deep ensemble architecture of diabetes prediction.
Is my screen visible?
Yes.
Okay, good morning to everyone. I'm Harshna Makwana, along with my co-authors Ayushi Chaudhary and Deep Kotharia. So, diabetes is one of the most common chronic disease worldwide that affects millions of people every year. Early diagnosis is extremely important because the delay of the diagnosis can lead to many diseases such as kidney failure, vision loss, nerve damage. So, in this study, we focus commonly on available medical parameters to investigate whether the XML learning can provide better prediction performance than individual machine learning or not. So, here we can see that the diabetes is a critical global health challenge which prevalent in both developed and developing nations. These are these are the people that is being affected. This is the proposed study, and this is the 1 second. Yes, and this is the higher individual MN machine learning models. Now, this is the literature review. Now, in this, I have collected the papers which are highly focusing on the diabetes and also on the machine learning models. Like, for example, we can see the first one, IDF 2019. It says that the overall 460 million people worldwide have diabetes. Majority of that are found in Saudi Arabia. That is a key risk factor, including urbanization, aging population, obesity, and the low physical activity. Whereas we can see here in 2024 people, which focuses on the random forest. Random forest shows the best accuracy of 93.03% on UCI dataset with 520 reports from Bangladesh hospitals. Whereas on the third paper, we can see it is on an Indian dataset which have achieved 89% of the accuracy of the tenfold cross validation, and performance was reduced by key-fold validation. Whereas here in 2005 paper, we can see that the machine learning model for diabetes prediction is confirmed in benefit of XML approaches. Same goes for the 2023 paper and for 2021 paper. Now here comes the methodology. So our methodology begins with the 4 machine learning models that act as the base learners. The first machine learning model we can see is the logistic regression, LR. Logistic regression gives us the probability between 0 to 1 using the sigmoid function. It identifies linear relationship between independent and the dependent. It is simple, it is efficient, and it performs well when relationships are features and between features and are approximately linear, like 0 or 1. The second one, we have the decision tree. Decision tree Decision tree is a data through a hierarchical structure consisting of root nodes, branches, leaf node, each split determined using entropy and information gain. So the final leaf node indicates whether the patient is diabetic or not. And the third one we have used is the random forest. Random forest is a combine of multiple decision tree. It uses node size, tree count, features as hyperparameters of classification. This reduces the overfitting and improves the generalization. The fourth one we have used is SVM model, support vector machine model. So support vector machine model is by finding an optional hyperplane that maximizes the separation between diabetic and non-diabetic patients. This is the proposed deep learning XML architecture. So in this slide, we have proposed the whole architecture which we have used in our paper. The process begins, sorry, okay. The process begins with the data pre-processing where the missing values are handled and features. That is here in our input. That are 2 data sets we have taken. Instead of directly combining them with the prediction, we have extracted them into these 4 database models. These outputs are then passed to a feature of a fusion layer, that is this, and where the information of all the models is combined into an undefined feature space. After the fusion model, we have employ an XC boost that is a meta learner. XGBoost analyzes the combined outputs from all the base models and then learn the appropriate importance of each model prediction, whether is this LR is performing better or SVM is performing better, DT is performing better, and all this for matter, which is done by the XGBoost code. Then we have this dataset overview. So first, we have taken two datasets. The first one is the binary dataset from the Kaggle, and the second one is a multicast dataset. So the binary dataset in this, we were given the features like glucose, BMI, insulin, and the feature type was fully numeric, that is 010101. The use case was of, is the patient diabetic or is the patient non-diabetic? The second one is the multi-class diabetic dataset. The dataset is and the data is a multi-class classification, and the features that were given to us is HbA1c, so LDL, and feature type was numeric and categorical, and the use case was stage-wise diabetics classification. Here is also the graph which we made by ourselves on based of the age. Like for example, if we take a person who is diabetic at 45, at the age of 45, so what are the symptoms that he is providing? The same is for the person who is diabetic at the age of 30, the person who is diabetic at the age of 60. So this is the graph of that. Now here we are giving the individual machine learning model performance. Now, as I've told that we do four machine learning models: logistic regression, decision tree, random forest, and SVM. So in this model, the the accuracy which we have achieved is the precision, recall, and FN score. This this is the output of it, and this is the graph of how each and every model was performed. Then comes the Example stacking classifier, which we have used in the paper. So the Example stacking classifier gives us overall accuracy of 98.78%. The precision and the recall are 0.99, and the best and it is working best on it is the stacking is working best rather than voting and boosting in our research paper. Then the second comes of the voting classifier. The voting classifier, this is the graph of the voting classifier, that is the model performing good or not. Good or not. Then comes the comparative analysis of state of the art techniques. Okay, so the result shows that the example consistently performs traditional machine learning models such as logistic regression, decision tree, random forest, SVM, and even on standard XGBoost. For both binary and multi-class classification tasks, our architecture achieves a superior accuracy. These findings validate that the effectiveness of our deep assembled frameworks. Then coming on the conclusion is our model combines all the four models, that is LR, decision tree, random forest, SVM, through the feature of stacking and XGBoost based on the meta level. The proposed architecture also achieves like 98.78% of accuracy while outperforming the voting and boosting with 98.1% and boosting with 98.54% of methods. The third one, the deep assemble model is consistently outperforms all individual machine learning models across both binary and multi-class dataset. This study also demonstrates that the importance of feature selection, focusing on the most relevant parameters, significantly improves the model accuracy. The study also demonstrates that the selecting of the most relevant medical feature significantly improves the predictive performances. In the future, this framework can also be extended to the larger healthcare data set and integrate into real-world clinical decision support system. These are the references which we have taken, which is used in our research work. And yeah, that's it. Thank you. I'm down for any of the questions you want to ask.
Can you please come to the references?
Yes, sir.
Okay, and which is the base paper over here?
Best paper. Sir,
Main paper,
I don't
main
know.
paper, yeah. From where you have
Main
collected the
paper?
information and the data sets.
No, sir, that is not a main paper. I have collected through many papers, and the data set was collected from the Kaggle. There were two data set, and both of the data set are collected from the Kaggle. And the binary data set in which it was already given that the person is diabetic or not with the data set with the output of 0101. So we only had to predict that is this person diabetic or not. Whereas in the multi-class data set, it was not given. We were given is insulin is high or not, or
This
BMI
type of
score is
work
high or not.
already also done, but what is actually your main uniqueness of the work?
So the main uniqueness of the work, as you can see, first of all, we have combined this one. Then now see, so in this we have not taken a particular output of each and every model. We have combined all the outputs and then we have applied the XCBoost score and then we have applied the future Fusion score. So what happens with this is that the overfitting reduces and the effectiveness of the overall model improves. So that is the reason that our model is giving like 98, stacking is giving like 98.78% of accuracy. So, sir, we have combined all the four models and then we have taken the output of all the four models and then we have given it to the Fusion and the XGBoost model. That is the uniqueness, so that it improves the overall predictivity, it improves the overall prediction that is the person like diabetic.
Yeah, yeah. Okay, thank you.
Thank you, sir.
Thank you for your presentation. At last, we have Karthik Totlani presenting the paper titled A Community Based Micro Equity and Trading Platform for MSMEs.
Yes, team. Am I visible? Am I audible clearly?
Yeah, you're audible and your screen is visible.
Yes. So, hi everyone. Good morning. So, the title of our presentation is Community-Driven MSME Micro Equity and Trading Platform. So, what this basically is that like MSMEs in India contribute to 30% of India's GDP, and there are more than 110 million. But how do these MSMEs get their financing or financing or equity-based loans or something where they can expand or invest more? So we are proposing a solution for them so that we can finance them based on their equity. Because the current problem is that the stock exchanges such as National Stock Exchange of India and BSE uh, often list the companies which are multinational companies, and they demand expensive compliance and have to follow the already preset SEBI regulations. So the gap we identified is there is no platform for retail investors to buy equity stakes. So these are not loans. This is not debts for MSMEs. They are selling their equities in return of an investment. So this has to be done with transparent, and there needs to be a different guidelines uh, to which SEBI can adapt, and a new governance can be set up here. So what we propose is a fractional equity investment in MSMEs. So assume it in a way like some investor is sitting is has some funds, and he basically wants to invest in a community which he uses regularly. Suppose if I'm an engineer and I regularly visit this restaurant at my place, so I create a bond and I understand like what their needs are. I want to invest. I like the food there. I like the people there. So this community shares are basically an idea wherein I can contribute a small bit of my funds and help them expand, help them cover their challenges in return of an equity, right?
So the motivation behind this was, as I said, MSMEs contribute to 30% of India's GDP, but they don't have any equity funding sources. There is equity democratization, societal impact as it binds our community growth, and again, it will have digital ecosystem prepared in informal sectors like MSMEs as well. So there will be growth of UPI, there will be a Aadhaar-based KYC, and it will bring the MSMEs to the digitalized and formal sector of India. So the literature survey that we did was we this part of this was already implemented in Indonesia, as we can see the Indonesia equity uh, CFOJK paper. So this was again a sandbox uh, like environment wherein they tested this platform, and we took inspiration from this. But there are also other platforms like Grow is there, there is Upstocks is there, but again they operate on NSE and BSE, and it only lists the multinational companies registered within the SEBI regulations. So we propose to build a different alternative regulation for MSMEs. So if I could walk through my platform, so this is the testing platform that we have created. We can see we can start investing. We can discover MSMEs nearby us. If we can go on map, I can see it within Pune, Mumbai, New Delhi. I will just try to have one sign in. So since we are yet into the testing, we have hard coded few things. But yeah, so this is paper currency as of now. I can see what my investments are. I can place trade orders. Uh, this is the ask owner wherein I can ask the owner what I need. Order book is there, and I will. These are notifications that I get after successful order. Um, Go to MSME owner. If we see MSME owner, then he is able to see Riya Sharma has invested these many investment for these shares. The amount of equity diluted. There are more requests. If anyone raises more requests, I need to accept it here from. And coming to the core business, like how will MSME register on our platform? So there are inspection visits. We have to submit documents. We have to submit GST or PAN card, financial statements, bank statements. We have to list our profit here. So I will come back to my presentation. So MSME registration and verification is done using KYC, GST, and the financial data of theirs. Then we generate a fraction of community shares based on the profit that the MSME lists on our platform. And this works in both the ways, because the better the profit and the transparency that MSME will give, even after the inspection visits, the better investments they will get, the better trust they will build with the shareholders. So uh, the next is ownership on blockchain ledger will be recorded. There will be escrow-based fund management until target is achieved, and automatic profit distribution to the shareholders. This is the workflow for our platform. Like MSME gets approved, there are shares minted on equity token. Investor can buy them. If target is not met, the funding remains open. Funding limit is reached when targets are met or if the deadline is missed. So as we are aware, even on Grow and Upstocks, we can trigger our orders. So something like that we have planned here. MSME operating active, we need to upload our profits, then dividend payouts will be issued. Investor will sell shares, new owner can buy those shares. So this is the working. This is our system architecture, wherein we have web and mobile application at the presentation layer. We have APIs and authentication services. Core backend services include few of algorithms and trading engines that I will talk about. And data layer, we are using Redis and MySQL. So external integrations are Aadhaar KYC API, UPI banking database, and the blockchain layer includes the smart contract systems and dividend smart contracts and equity smart contracts. So the advantage and the scope for this is, like, this has a massive market size. India has 6.5 plus crores of MSMEs, and it is projected to reach to about 9 crores in 2029. And with more startups and more small scale industries thriving in the current development stage of India, we need to look for their funding as well. Um, as I talk about funding, there is a credit card opportunity that is only 16% of MSMEs have access to formal bank credits, and 84% still rely on informal finance. So informal finance is basically loan or P2P lending platforms which demand high interest. So limitations, as I talked, technical feasibility is also there. Most of the MSMEs are not aware that there are some certain platforms existing for them or formal ledger systems. So uh, if we bridge them to the digital readiness of India, we can somehow reduce this. The limitations for our platform is there is a risk of MSME failure, because whenever we talk about a new skill industry, there's always a risk of failure. So what we can do for this is we can have inspection visits, we can have more awareness, we can have uh, like a more transparent filing of profits, which is somewhat catered by our algorithms. Um, so yeah, this was the platform. So I will quickly go to the algorithms that we have planned. So first one is MSME verification and listing. So this happens through MSME valuation. MSME valuation is again calculated by the amount of investment it has, the amount of capital that the MSME requires, and the percentage of equity it is ready to dilute. The second algorithm is community share issuance, and the third one is investor confidence scoring. So as I talked about, trust is very important factor in this. So we considered few factors like revenue stability, that is the variance of revenue in past few months, GST compliance, that is filings per 12 months, profit consistency, like out of 5 years, if a company has been profitable for 4 years, then the investor confidence score accordingly deviates from it. MSME age, the older the MSME, the more trust. So these are the factors to which we have added more weights. We can see how much weight we have given here. We have given 30% of weightage to the revenue stability and 20% to MSME age, right? The I have explained here with a example that, like, if the raw value revenue variance is 15%, then we get a normalized calculation out of it. So all these algorithms are working in our platform. Um, we have given an ICS range, like if it's greater than 70, then it's low risk, suitable for conservative investors. If it is less than 40, then it's high risk, and it's only suitable for the high risk investors who intend to get profits quickly. So when we say quickly, what like we can do trading every day, intraday at Grow and Upstocks, but our platform doesn't allow that. This is only allowed quarterly trading, because every company files their profits quarterly. So it's like a fixed window, a fixed deposit, but for a quarter. So if I want to share, I can share. And also there is a provision wherein if the investor wants his funds back between a quarter, then he can provide special request as I showcased in my platform to the investor. Investor can see those the MSME can see those requests and can approve it. So though that amount of shares will be restored to the MSME. The fourth algorithm is investment and escrow. So the investor selects the MSME and number of shares, and the funds are transferred to smart contract via UPI. So there are smart contract checks, authenticity of listing, and that fund limit is not surpassed. Once the target is met, then funds are transferred to MSME wallet. And if there is failure, then there is refund process triggered to all investors. So there is no intervention needed in this case. The fifth one is profit distribution model, which are equity based returns, which is similar as it works on the other platforms. Then the sixth one is secondary trading, uh, which allows to have bid and negotiation of price. So we also allow this from our platform. Then there is MSME valuation model. So there are different types of valuation that we are calculating. There is pre-money valuation, which is investment amount per equity offered. There is actual valuation, so which is calculated based on the last years of profit and the market multiple that we have. And the final valuation accounts both of them, the actual valuation and the risk factor and the confidence scoring. Uh, Yeah, so we intend to share that MSMEs generally have a high profit into their early years, which the investors can benefit from, and like we intend to give 15 to 25% of ROI on the investors to the investors, and this is beneficial for MSME as I say MSMEs get their funds to expand, to provide salaries to their employees, to think of new business perspectives. So it works both ways. Coming back to my presentation. So the study we also did was there are some more indicators that we were planning to take on, like cash inflow stability score, debt risk, because we are aware that MSMEs also have a certain debts before they start their business, right? So we can account from there, we can take in their civil scores, we can analyze the certain market factors because there are government policies that are coming in and which can disrupt a certain sector of certain MSMEs in a certain sector. So we can consider those factors as well to calculate our investor confidence score.
You may please conclude. Thank you.
Yeah. So the this project basically aims at a community-driven microequity platform that helps us solve the funding challenges faced by MSMEs. And side by side, the investors are get another platform to invest, wherein they are getting more returns on their investment. And this will make a SEBI to form a regulatory board for MSMEs as well. If there are more platforms like this and there is more like more user activity on such platforms. Yeah. Any questions on our presentation?
You have done a good job. No question, but try to submit a good paper in journal as well. It's a good work. As a student, I think you are working. It's a good
Yeah.
work you have done.
Yes.
And
you.
I think you might have used Claude. So
For the development,
if
yes, yeah.
yeah. So
Yeah,
for the
for
development fully, you have used Claude.
so the algorithms that I presented in my paper, all of these seven algorithms are there, and we have designed them on our own. The study, we have the factors identified, the research that we have done. As I mentioned about the Indonesia paper, so we took in some inputs from there. But again, those sandbox environments don't suit the SEBI regulations present in India. So we needed to modify a few things. So the
Okay.
algorithms is the unique thing that stands for us.
Okay, fine. Good work. Thank you.
Yes, thank you, sir.
Thank you, Karthik, for your presentation. And with that, we've come to the end of technical session 4E. I sincerely thank all the authors for the excellent presentations and valuable research contributions. I also thank all the participants for being a part of this session of the 11th International Conference on Information and Communications Technology for Sustainable Development, that is ICT4SD 2026. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend a heartfelt gratitude for your continued support, not only for the 11th edition, but also for the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I'd also like to express my sincere gratitude to our session chair, Dr. Tanupriya Chaudhary, for chairing this session and for his valuable time and guidance. As a token of our appreciation, we would like to present this certificate to you, sir. So would you
Thank you,
please like
ma'am.
to give
Thank you very much. Thank you, all of you.
Okay. I request everyone to switch on their camera so that we can have a quick snapshot of this session before we leave. Okay. Thank you everyone for joining today. I hope you have a great day.
Thank you. All the best.